Good day. Let's go over Pascal's triangle and binomial expansion. Okay, let's go over this first one here, x plus y to the fifth power. One quick thing needed to be noted is that however many terms we're going to be using is going to be this power plus 1. In other words, if I have x plus y to the nth power, the number of terms equals n plus 1 terms. Okay, we're just going to take the exponent, add 1, and that's how many terms are going to be in the expression once we expand it. So therefore, we're going to have 6 terms for this first one we're working with. So we could go ahead and write those out. Simply, it's going to look like this: x, y plus x, y, and we need 6 of them. X, y, 1, 2, 3, 4, 5, and 6. Okay, perhaps leave yourself a little bit of room in front of these because we're going to be throwing some numbers in there. And what we're going to do basically is this first term that we start off with, we're going to say the x is going to be to the fifth and y to the 0. Then for the next term, we're simply going to reduce it by 1, and the y is going to increase by 1. So we're going to have x to the fourth, y to the first power, then x cubed, y squared, x squared, y cubed, x to the first, y to the fourth, x to the 0, and y to the fifth. Okay, pretty simple pattern to follow. This one here, the x is going to start off with the exponent. It's going to decrease by 1 every time we go over. This is decreasing by 1. And y starts at 0 and is going to increase by 1 as we go along. Okay, pretty simple pattern. Next thing we want to do is we're going to look at here, okay, this is the fifth power. This is what we're expanding. We have 6 terms. And we look over here at Pascal's triangle, and we're going to find where on this line is the second number in a 5. And that's going to be right here, okay? So this is the line we're going to use. And these numbers here are going to be the coefficients that we're going to be adding in front of these terms. So looking here at the line, I'm going to say, okay, that's going to be a 1. This is going to be a 5. This is a 10. This is a 10. This is a 5. And this is a 1. Okay, pretty simple, pretty self-explanatory. We're just taking these terms and putting them out front here. And there you go. There's the first one expanded. That's what we get. So I want you guys to keep in mind that anything raised to the 0 power equals 1. So anywhere that there's a 0, something to the 0 power, we could kind of make it disappear because it's just being multiplied by the number 1. So our final answer, we kind of get x to the fifth plus 5x to the fourth, y plus 10x cubed, y squared, plus 10x squared, y cubed, plus 5x, y to the fourth, plus y to the fifth. And there's our answer for this first one being expanded. There we have it. Now I want to go over another one, perhaps one that we throw in a number as a coefficient, such as this one with the number 2. Maybe what happens when there's a minus sign. So let's just jump right into it. Let's do this one next. X plus 2y raised to the fourth power. Okay, first thing we want to know is how many terms are going to be. Remember, it's going to be the exponent plus 1 n plus 1 terms. So therefore, we're going to have 5 terms. What we could do is go ahead and write those out. We have x and 2y plus x and 2y plus x and 2y Okay, then we want to start off with putting the fourth power here. This term is going to be raised to the 0 power cubed. So the first power squared to the second power. This to the first to the third power. And then 0, and then this to the fourth power. Okay, pretty simple. Next thing we want to do is we want to look over here at Pascal's triangle. Find where the number 4 is the second number in, which is this row here. And those are our coefficients. So we have a 1, a 4, 6, a 4, and a 1. Okay, next thing we want to do is we just kind of want to do the math. So the first one here, we have x to the fourth, 2y raised to the 0 power is just going to be 1. So we're going to say that we have x to the fourth. Then we're going to add 2y raised to the first power. 2y raised to the first power is just 2y. And since this is all being multiplied together, we can multiply these coefficients together. So we're going to have 8. 4 times 2 is 8. X cubed y. Okay, the next term, 2y squared, 2y squared is going to give us 4y squared. Okay, 2 squared is 4, y squared is y squared. So 4y squared times 6x squared is going to give us 24x squared y squared. Okay, next term, 4x to the first power, 2y cubed. Okay, 2y cubed, well, 2 times 2 times 2, that gives us 8. And then a y cubed, so 8y cubed. 8 times the 4 will give us, 8 times 4 is 32. So 32 x y cubed. Okay, the next term, x to the 0 is just 1. 2y to the fourth, that's going to be 2 times 2 times 2 times 2. It's 4 times 4, that's 16. So we're going to have 16 y to the fourth power. And there you go, there's this one expanded. So once it's all said and done, once we expanded this is what we get as our answer. Okay, let's go over one more, x minus y cubed. So we're going to have 3 plus 1 terms. That's going to be 4 terms. So we're going to say x times minus y plus x times minus y plus x times minus y. Okay, then we start off putting a cubed here, 0 power here, squared and 1, 1 and 2, 0 and 3. Okay, using our same pattern as before, it's decreasing by 1 on the x exponents and increasing by 1 on the negative y exponents. Next thing we want to do is we want to look here, where is in Pascal's triangle, where is the number 3, the second one in? So it's going to be this row here. And those are going to be our coefficients. So this 1, this 3, and the 1 are going to just go on down here. So we got a 1, a 3, and a 1. Then doing the math, x cubed because this negative y to the 0 equals 1. Anything raised to the 0 power equals 1. It kind of goes away. Okay, the next one, 3x squared minus 1 to the first power is just going to be negative 3x squared y. The next one, the next term, negative y squared is going to give us a positive y squared. 3x and positive times positive y squared is just 3xy squared. And the last term, we're going to have, this turns into a 1. Negative y to the third power is just negative y cubed. So our final answer we could say is x cubed minus 3x squared y plus 3xy squared minus y cubed. Okay, so this is the shortcut on how to use Pascal's triangle to expand these binomial expressions. I hope you guys can use this. It's a very good shortcut if you need to use it. Okay, the next thing I want to go over with you is what a factorial is. So here are these, we call these factorials, this exclamation mark. So I guess the easiest way to explain it is here, 5 factorial. What 5 factorial is just going to say 5 times 4 times 3 times 2 times 1, just going down 1 every time. So if I have n factorial, it's just 1 times 2 times 3 times 4, dot, 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 all the way up to n, whatever your number n is. So, if I have 4 factorial, it's just going to be 4 times 3 times 2 times 1. Okay, another way to write that is n factorial equals n times n minus 1 times n minus 2 times n minus 3, dot, 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 dot. And it just keeps going in the same similar pattern. The other thing to keep in mind is that 0 factorial equals 1. Okay, if you ever see 0 factorial, that equals 1. So pretty simple. It's just, you just subtract 1 as you go along. Okay, now I want to go over a couple exercises with you with factorials and then get into the binomial coefficient and show you how that relates to Pascal's triangle and expanding these binomial expressions. Okay, let's just start with a simple one. 5 factorial divided by 4 factorial. So you could say that equals out to 5 times 4 times 3 times 2 times 1 divided by 4 times 3 times 2 times 1. Okay, now you just simply cross out, and what we're left with is just the number 5. Okay, so what if I have something like 6 factorial divided by 2 factorial? What does that equal? So we're going to say that equals 6 times 5 times 4 times 3 times 2 times 1 divided by 2 times 1. Okay, simply do this. What we're left with is 6 times 5 times 4 times 3. So that's going to be 30 times 12. 30 times 12. Well, 30 times 10 is 300. 30 times 2 is 60. So 300 plus 60 equals 360. Okay. So this is pretty simple. This is 1 factorial divided by another, and this is how you find the answer. You just kind of go through this motion here. Okay, what if we have something that looks like this? 5 factorial divided by 3 factorial times 2 factorial. Okay, same kind of thing. 5 times 4 times 3 times 2 times 1 divided by 3 times 2 times 1 times 2 times 1. Okay, this 3, 2, and 1 could go cancel out with that. So what we're left with is 5 times 4 over 2 times 1, which equals 20 over 2, which just equals 10. Okay, so if you see 2 factorials being multiplied together, you could kind of just write them out. 3 times 2 times 1 times 2 times 1. All right. Okay, what if we have something like this? 3 factorial divided by 3 factorial times 0 factorial. Okay, that's just 3 times 2 times 1 divided by 3 times 2 times 1. And remember what I said, that 0 factorial equals 1. So I'm just going to say times 1. So you cancel those out. What we're left with is 1 over 1, or just 1. Okay, pretty simple. This is what we call factorials. This is how you handle factorials. Now I want to show you what the binomial coefficient is and how this relates to Pascal's triangle and expanding the binomial expressions. Okay, this is the definition of a binomial coefficient. You'll see this kind of thing a lot if you get into statistics. If you want to calculate the odds of a horse race. If you're into gambling and you want to know the odds of your horse winning, this is the kind of stuff that you'll be doing in statistics. But for our case, we just want to go over this and show you how it relates to Pascal's triangle. Okay, so what we have here is n has to be greater than or equal to r. Okay, n has to be greater than or equal to r. And the way we say this is we call this n choose r. N choose r. And then we have, of course, n factorial divided by n minus r factorial times r factorial. Okay, so what does this all mean? Okay, so what this kind of means is this number n, it's going to be a number, that the number n, so this binomial coefficient is going to be the n plus 1 numbers in row n plus 1. So if I want n to equal 3, let's say n equals 3. Okay, that means it's going to be n plus 1 row, and it's going to be n plus 1 numbers. So n plus 1 row, that means 3 plus 1. 3 plus 1, that equals 4. So the fourth row, okay, the fourth row, n plus 1 rows. So there's 1, 2, 3, 4. So here's the fourth row. Okay, now you also notice that there's 4 numbers in this fourth row. That's where we get this n plus 1 numbers, n plus 1 numbers in this row. So if I wanted to have something like 3 choose r, find the values for r equals 0, 1, 2, and 3. Okay, pretty simple. We're just going to kind of plug these numbers into our formula. So let's try the first one. Let's say 3 choose 0. Okay, 3 choose 0. So that's going to be 3 factorial divided by 3 minus 0 factorial times 0 factorial. Okay, so we have 3 times 2 times 1 over 3 times 2 times 1 times 1. These kind of cancel out. What we're left with is the number 1. So 3 choose 0 equals 1. And what that means is this 1, that's going to be this number 1 right here. Okay, let me show you another one. Okay, how about 3 choose 1? So that's going to be 3 factorial divided by 3 minus 1 factorial times 1 factorial. So we get 3 times 2 times 1 over 3 minus 1 factorial, that's 2 factorial, so that's going to be 2 times 1. And then 1 factorial is just 1 times 1, which is 1. So what we're left with is 3. And you could see this 3 here. That's this number 3 here. Okay, so if I have 3 choose 2, it's going to be 3 factorial over 3 minus 2 factorial times 2 factorial. So what we're left with is 3 times 2 times 1. 3 minus 2, that equals 1. So 1 factorial, that's just going to be 1. Times 2 factorial is 2 times 1. Okay, this 2 times 1 and this 2 times 1 cancel out. What we're left with is 3 over 1, or just 3. Okay, and that number that we just came up with is this second 3, this one here. Okay, one more. Okay, 3 choose 3 is going to be 3 factorial over 3 minus 3 factorial times 3 factorial. Okay, 3 factorial is 3 times 2 times 1 times 0 factorial times, well, we know 0 factorial is 1. Where do we get the 0? 3 minus 3. So 0 factorial is 1. And then this other 3 factorial, 3 times 2 times 1. Okay, this one and this one cancels out. What we're left with is 1 over 1, or just number 1. And that number 1 that we just came up with is this number 1 here. So this is what we're kind of doing when we're doing this binomial coefficient. Is you can see that this is another way. Let's say that you didn't want to write out this Pascal's triangle for whatever reason to do your binomial expansion. That if you wanted to find the number, a specific term, you could use this formula to go ahead and find that. Yeah, I'll kind of show you guys what that looks like. Okay, here's the formula to find the any term. So the r plus 1 term in one of these expansions. Simply, here's the formula. N choose r to the a to the n minus r, and b to the r. Okay, so what that kind of means is, let's say I have a problem that shows you a plus b to the 5th power, and they want us to find the third term in that sequence. Remember, we made all those terms, so we want to find what is the third term in this binomial expression here, a plus b to the 5th. So we know that r plus 1 is the term, is going to be the third term. So r equals 3 minus 1, or r equals 2. Okay, and we know that n equals 5. We got that n equals 5 from the exponent. Okay, so we wanted to find the third term, so we're going to say r plus 1 equals the third term. So therefore r equals 3 minus 1, or r equals 2. Then we just kind of fill these numbers in to our formula here. So we have 5 choose 2. Okay, and let's go ahead and I guess we could also say this 5 minus 2, 5 minus 2, and b to the 2nd power. Okay, so let's look at what is 5 choose 2. I'll do that over here. 5 factorial over 5 minus 2 factorial times 2 factorial. So we have 5 times 4 times 3 times 2 times 1. Divided by 5 minus 2 is 3. 3 factorial is 3 times 2 times 1. And then 2 factorial is just 2 times 1. So these cancel out. What we're left with is 5 times 4 over 2 times 1. So that's 20 over 2. That's going to be 10. So we know our coefficient is 10. Then we're just simply going to say a to the 5 minus 2 is a cubed, b squared. So there is the third term. And remember, we kind of did the shortcut. That's why I consider the Pascal's triangle a shortcut. Because if you don't use Pascal's triangle, you have to go through all this kind of stuff to figure it out. So that third term, that's going to be this guy right here. Okay. Remember, we had the fifth power, the exponent. So we went over here. We looked at the second number in, which is a 5. Okay, and the third term. So there's our coefficient. So this is basically what we're doing when we're using the Pascal's triangle as a shortcut. Is this kind of 5 choose 2, you know, a to the 5 minus 2 b squared. So I hope you guys got something out of this. I know it's if you've never seen it before, it's kind of tough, but just keep in mind this Pascal's triangle is just a really great shortcut when you want to expand your binomial expressions. I hope you guys got something out of this. If you like these kind of videos, just press the like button and leave a comment below. Thank you.